problems on Trailers and Maclurin's expansion, the question is obtain the expansion of e to the power of x by Maclaurin's method. Now in this answer is fx is e to the power of x, f dash x is also e to the power of x, up to so and so forth. Fn of x is also e to the power of x. We know the see, you can use two different approaches. The number one approach, you use this formula straight away for the infinite series. Maclaurin's infinite series. You write this infinite series, and this is valid for this interval 0 to x. Now you have fx equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 and so forth till infinity. Now here fx is e to the power of x, f0 is also e to the power of 0, that is 1, f dash 0 is also e to the power of 0, that is 1, and so forth. All fn0 is also 1. So this goes on, these all terms become 1, this all term becomes 1. So now what you have is, in this you have fx, what is fx? E to the power of x, f0 is 1 plus x into 1, you need not write this because this is f dash 0 is 1, this f dash 0 is 1, so no need to write. It is x square plus x square by 2 factorial plus x cube by 3 factorial and so forth. This is one approach. The other approach is you go by the definition itself. That is, you write fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 and so forth till Rn plus Rn, where Rn is the Lagrange form of remainder. Where Rn is x to the power of n factorial fn theta x. Now you consider this thing from here. Consider this. Consider some an. Define this as x to the power of n upon an. जो ये वाला टर्म है, जो this term, you define this as an. जो ये वाला टर्म है, ये वाला टर्म पूरा, इसको define करो an के तरह. Let us consider this as an. Consider. So let us rub this all now. Now there is a result in real analysis. The result is for any, this is an is a sequence a1. See, ये एक sequence है, an एक sequence है, तो a1 क्या होगा? x comma, अब देखो next see a2 comma, a2 is nothing but x square by 2 factorial. Similarly a3 is x cube by 3 factorial and so forth. Now this there is a result in real analysis. I'm writing down just the result. Suppose these are the sequence a1, a2, a3. These are the sequence of this an up to an. Let us say an is xn upon n factorial. This is a sequence, and there is a result on sequences. If limit n tending to infinity an plus 1 upon an is equal to L, where this mod L, whatever this L may be, mod L should be less than 1, then limit n tending to infinity an is always 0. See, एक रिजल्ट है रियल एनालिसिस में, अगर इसको एक सीक्वेंस मान लिया जाए an का, a1, a2, a3 up to an, तो एक रिजल्ट है an plus 1 upon an equal to L, where L mod L is less than 1, the limit n tending to infinity an is 0. This result is not in your syllabus. The big problem is this. The result is not in your syllabus in this BCA of your GGSIPU. This result is not there I have not seen in these books. But this you can apply. There is no problem. This is a valid, very important result. Rather a theorem of real sequences. Now see one thing. Here what you have an. Use this result. So limit n tending to infinity, you must always write this, इसको जरूर लिख के तब ये रिजल्ट यूज करना. an plus 1 upon an is nothing but limit n tending to infinity x to the power of n plus 1 upon n plus 1 factorial into, now this will be opposite way, x to the power of n factorial. Now what you do is that, इसके बाद क्या करो, what you do, limit n tending to infinity x to the power of n into x, this one will break, into n factorial upon n plus 1 into n factorial, expand this, and x to the power of n, this will cancel with this will cancel with this, you are left with the limit n tending to infinity x and n plus 1, and this will go to 0. So this, as this goes to 0, therefore according to this result, you have therefore limit n tending to infinity, limit n tending to infinity, an is 0. Now an is what? That means limit n tending to infinity x to the power of n upon n factorial is 0, and this is 0. अगर ये 0 है तो of course this Rn is also 0. This Rn is also 0 because this quantity is 0. This quantity is 0 as n tends to infinity. ये क्वांटिटी 0 हो जाता है as n tends to infinity पे, और ये 0 होने के कारण Rn भी 0 हो जाएगा as n tends to infinity. Therefore see, as n tends to infinity, Rn tends to 0. So the Maclaurin's theorem now goes for an infinite. So Maclaurin's infinite expression, Maclaurin's infinite RIN, sorry, I made a mistake. RIN. Maclaurin's infinite. This series becomes fx f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial 3 factorial f triple dash 0 third derivative, and so forth. It goes on and on. ये चलता ही रहेगा. So अब e to the power of x, this is f0 is 1, x into 1, no need to write, this is just x square by 2 factorial, x cube by 3 factorial, and so forth. This is the way you will do it. Next, let us take another question. Let's take another question. Question is, find the Maclaurin's expansion for fx is equal to cos x. Find Maclaurin's expansion. Find Maclaurin's expansion. Maclaurin's expansion. And you know that one thing I have told you in my nth derivatives, f of x is cos x. Now f dash of x is minus sin x. This is minus sin x. That means this is equal to cos pi minus sin x. That means it is cos pi by 2 plus x. Now f double dash x is, take this is minus cos x, this is nothing but sine, this is nothing but this is nothing but minus cos x, this is cos x minus sin x. So in terms of cos, now this becomes the nth derivative cos, this becomes 2 into pi by 2 plus x. So this is nothing but cos pi plus x, and cos pi plus x is nothing but minus cos x. So this is the important thing. जब यहाँ पे 2 होगा तो यहाँ पे 2 है, जब यहाँ पे 1 है तो there is a 1 here. Basically when there is a 1 here at first derivative, there is a 1 here. When there is a 2 here, then you put a 2 here. So f and x becomes cos n pi by 2 plus x. Now see, we need to understand इसको अगर मैं, if you need to expand this, find Maclaurin's expansion, sorry, expand, not expand. I forgot to write the complete thing. Wait a minute, it is expansion. Expansion. This was the question. Now this, now you see what is Rn. Rn is x to the power of n upon n factorial fn theta x. fn theta x. Now what you do is that, so in this case, इस केस में ये बन जाएगा x to the power of n factorial cos n pi by 2 plus theta x. Now see one thing, mod you take, what you take mod Rn you take. So mod Rn is mod of x to the power of n factorial cos n pi by 2 plus theta x, and then this is equal to mod x to the power of n factorial mod cos n pi by 2 plus theta x. Now remember one thing, I told you earlier also, sine mod is less than equal to 1, cos mod theta mod is less than equal to 1. This quantity is less than equal to 1. That means this is less than equal to mod x, so mod upon n factorial, x to the power of n, just a minute, x to the power of n, let me take some space, x to the power of n, x to the power of n upon n factorial. Consider this as the now as in the earlier example, consider this as an is x to the power of n factorial. Now using that concept of limit n tending to infinity, an plus 1 upon an, you know this result already I did in I was doing it in the previous question. This comes out to be x over this comes out to be, ये आ जाता है limit n tending to infinity x upon n plus 1, and this comes out to be 0. Therefore limit an is equal to this an is equal to 0. Therefore this Rn goes to 0. Therefore this Rn is maximum, it can go to 0. See, basically mod Rn cannot be less than 0. So mod Rn, this if I write like this, because this is going to 0 as n tends to infinity, तो mod Rn, it is a mod. So mod होने के कारण less than 0 नहीं होगा, ये सीधा mod Rn चले जाएगा 0 पे. The mod Rn will go to straight 0 because mod value cannot be less than 0 as n tends to infinity. Therefore now you have your Maclaurin's expansion as fx is equal to x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0 and so forth till infinity. So fx is what? Cos x. What is f dash x? What is f dash x? I just told you it is cos pi by 2 plus x, right? What is f triple dash x? It is cos double dash x. This is single dash. Sorry, this is single dash. This is single dash. This is now double dash. Now this is double dash. Second derivative, that is cos 2 pi by 2 plus x. Now cos triple dash x is cos 3 pi by 2 plus x. Now at 0 pe f of 0 cos 0 is 1. Similarly f dash 0 is cos pi by 2. Cos pi by 2 is 0. Similarly f double dash 0 is cos pi, and this is nothing but minus 1, because if you put a 0 here, 2 and 2 will cancel out and you will get cos pi. Cos pi is minus 1. And now f triple dash 0 is nothing but cos 3 pi by 2, and this is again 0. Therefore cos x can be written as, using this result, this complete expression, you can write cos x as f of okay, I forgot to write one thing here. Just a minute. I forgot to write fx equal to f of 0 plus x. This thing I forgot to write. Now cos x is equal to x f of 0 cos 0 is 1. Now plus x f dash 0, that is 1 plus x, then 1 plus x f dash 0 x of f dash 0, yes, f dash 0, yeah, f dash 0, what is f dash 0? F dash 0 is 0, sorry, f dash 0 is 0. Then you have minus x square by 2 factorial, f double dash 0 is minus 1, this is plus, you write, this is minus 1. then plus x cube by 3 f triple dash 0. F triple dash 0 is 0, 3 factorial. I'm forgetting to write the factorial. F triple dash, this is 3 factorial. F triple dash 0. F triple dash 0 is 0. ये 0 हो जाता है, and so and so forth. Therefore, cos x, expansion of cos x, 1 minus x square by 2 plus, this will come all in evens, plus now it will be x4 by x2 by 2 factorial, x4 by 4 factorial minus x6 by 6 factorial, like this it will come.